Hello and welcome to another video of this video series about object-oriented programming. In this introduction video about Constructor, I'll deal with the problems that we've come across in the last version 1.3. To summarize the problems in the previous version, we had two problems. The first problem is that whenever we want to create an instance and initialize that instance with some specific values, we need relatively a lot of code just to create and initialize an object. 5 lines in our case. 1 for instantiation and then the 4 setters. So there's some redundancy here. What is the solution? Constructors. The second problem we face, whenever we create an instance and don't set to some specific values but print the instance immediately, what do we note? Well, that the object is actually in invalid state. X and Y, they may be 0 according to the specifications, but not height and width. So rectangle has invalid height and width, and then the question is, well, whenever I create an object as demonstrated here, is there no way to provide default values so that the result will be height 10 and width 10, for example? Solution, again, constructors. To tackle the first problem, what if we could pass initial data in one go? Meaning, instead of passing the values for x, y, height and width via the setter separately, wouldn't it be nice if we could pass them together with the instantiation of the class, and thereby resulting in the desired outputs? Well, that is possible. How? By implementing a 4 parameters constructor in a class rectangle. What is a constructor? Well, it is like a method with a few differences. The name must be the same as the name of the class, rectangle, and there's no return type specification, so no void or int or whatever. For the rest, you can define parameters, 4 in this case, and then you enter the separate statements in a code block. Whenever an instance of a class is created and with that instantiation we pass 4 arguments, the runtime will look for an existing constructor with the same amount and type of parameters. So we are passing 4 integers, so the runtime will execute automatically the implementation of this constructor, passing the 4 arguments to these parameters. X will have the value of 10, Y of 20, height of 100, and width of 200. Once that is done, the value of those parameters are then used to be assigned to the corresponding properties. When the execution reaches the closing brace, control is back in the main and then perform the print. So the invocation happens automatically. Now just a note about the term 4 parameters or arguments. In literature, you quite often read about a 2 arguments constructor. 4 arguments constructor. Now, I prefer to use the term 4 parameters constructor because the actual constructor is implemented in the class with its parameter lists. So here, 4 parameters. What you pass via the client, on the other hand, are called arguments. So we pass arguments to the corresponding amount of parameters. But actually, if you talk about a constructor, the constructor is what you implement here. I think you should then use the term parameters and not arguments. Anyway, so that's why I put it behind these round brackets, the args for arguments. Okay, this implementation solves the first problem. So when we create an object, we don't have to call these setters after the instantiation. When this statement is executed and when we print the object is in the desired state. So this single line replaces the 5 lines of redundant code we had earlier. Now when I say solves first problem, almost. We'll see that a bit later. So what is a constructor? It is like a method that bears the same name as the name of the class. No return type specification, so no void, int or whatever. Invoked automatically when an object is created. And important to note is that it doesn't create the object. New does that. Because once the constructor is executed, the object already exists. We have access to the object via the this pointer. So this implies that the object already exists. So it is used for initializing the object. Now we have a new problem. The previous code doesn't compile anymore. If we would execute this code, then we get a compiler error while trying to create the second object. And the compiler error is cannot resolve constructor rectangle empty parameter list. Why is that? Well, it is that the previously by the compiler automatically generated default constructor is not generated anymore. Before the discussion of these constructors, we never had a problem with new rectangle without any arguments, and now all of a sudden we have. Why is that? Well, the rule is that as long as you don't implement a constructor yourself explicitly, then the compiler will automatically create a what we call default constructor for you. That is a constructor that doesn't have any parameters. So it can be invoked automatically without having to pass any arguments. Now, from the moment you do add a constructor explicitly, which is what I've done here, I've now added a 4-parameter constructor in the rectangle class, well, then the compiler doesn't generate this default constructor anymore. And that results then in this compiler error. The only way now to create an object is by passing 4 arguments. So this is not possible anymore. If the client nevertheless really wants to be able to create an object without having to pass any arguments though, then we can satisfy the needs for the client by adding a default constructor explicitly ourselves. So default constructor solution, add a default, no parameters, no arguments, constructor explicitly. So it's another constructor, so it bears the same name as the name of the class, no return type specification, but no parameters. And what you can do then is, because we don't want the object to be in an invalid state, and that was the second problem, well, what we can do then is assign some default values to the height and width property. The minimum, according to specifications, was 10. So we define via these constants. I am a big fan of constants, and you'll see why I'm using these constants here already, because in future videos you'll see that this approach will become very handy. So what I do here, I define the 2 constants, minimum height and minimum width, and I assign them to the corresponding properties. And actually, in general, using constants has another advantage. Namely, it makes the code more readable. Because if we would just assign the values of 10 directly to these properties, somebody reading your code or you sometime later might wonder what those values stand for. Using constants, on the other hand, clearly gives a meaning to the values of 10 and thus makes the code more readable. Okay. That results in the client not having a compiler error anymore, because now when new rectangle is executed, the runtime automatically jumps to the execution of the default constructor, initializing height and width to the provided values, and when returning and printing out the object, we see that the second line, we see that the object is in a valid state. So the addition of the default constructor solves the second problem. Just a final note about whether you should use the term parameters or arguments when referring to a constructor. My recommendation is just avoid the term arguments altogether when referring to constructors, such as no arguments constructor or 4 arguments constructor. And especially in this example, very often you hear that since this constructor is explicitly defined now, that the name given to this constructor is no arguments constructor and not no parameters constructor, or just default constructor. This is misleading. I have a video about default constructor explaining why it is misleading, so I recommend you have a look at that video. Okay, so the addition of the default constructor solves the second problem of our object being in an invalid state. But we still have a problem. Another problem arises. Let's pass an invalid height. So we create here an instance using the 4-parameter constructor, our third argument representing the height. We decide to pass -100. By now we know that according to specifications it is an invalid height and should not be accepted. The minimum allowable height is 10. So what happens if we would execute this code? Our heights will be accepted and will be -100. And then I would go like, oh no, not again, because we solved this problem of invalid state in the previous version about encapsulation and validation but now we are faced with a problem again. How come? Well, because validation in the constructor is bypassed. So when the object is created, these 4 arguments are passed to the constructor. The height here will receive the value of -100, and that value will directly be assigned to its corresponding property, as are the other values. X, Y, height, width, they all are assigned directly to the properties. In the topic about encapsulation and validation, I demonstrated that assigning variables directly to a property may only happen after some validation has been performed, and we implemented all that logic in the setter. What is the problem here? Well, that the setters are not invoked. We must make sure that the setters are invoked. In other words, make it a validating constructor. Make sure that validation is performed during initialization. So within the constructors, instead of assigning the values directly to the properties, instead we call the setters. In the default constructor, set height and set width. In the 4 parameter constructor, the set x, y, height and width. Now, just a note, beware. Invoking a public method from a constructor might still lead to an incomplete uninitialized object. See later inheritance. What do I mean by that? Well, we are in a constructor and we invoke, so all the setters are public methods. As we'll see in the module about inheritance, this can still lead to an incomplete uninitialized object. But that's for later. Let's add some more constructors. So far we have the default constructor and we have a 4 parameter constructor. Now, constructors are generally added following how we want clients to be able to create objects. By implementing our 4 parameters constructor, we allow the client to specify the initial state of all 4 properties of a rectangle object. All the client has to do is to pass the 4 arguments x, y, height and width to the constructor. By adding our default constructor, we allow the client to create a rectangle without having to pass any arguments, though still ensuring the correctness of its initial state. Suppose now that we'd like to allow the client to create a new rectangle having the same properties as an already existing rectangle. For that, we can add a copy constructor. The client only needs to pass a reference to the existing object as argument to the constructor. The 1 parameter copy constructor with a parameter having as type rectangle will then invoke the setters by passing as argument via the reference the corresponding property of the existing object. So the client passes the reference, which will initialize the parameter rect. Hence, rect will then refer to the already existing object. Then using the x property of rect, so rect.x, we pass that value as argument to setx, rect.y to setY, and so forth, the copy constructor. Finally, suppose that we want the client to be able to construct a new rectangle by specifying only an initial height and width. For that purpose, we add a 2 integer parameter constructor. 1 parameter for integer heights and 1 for integer width, which will invoke the setters for both properties height and width. In a following slides will I demonstrate how all these constructors are invoked from the client. Our UML class diagram. So we have the instance member variables, our getters and setters and the methods. What is added now are our 4 public constructors. So the default constructor, copy constructor, 2-param, 4-param constructor. DrawingApp 1.4. Here's some client codes creating 4 rectangles. First one using the default constructor, second one the 2-parameter constructor passing 300 and 400, the third instance passing the 4 arguments, and the last object instantiation is using the copy constructor. So here we pass a reference to the existing object rectangle 3. By the time we print out the object here, the object already exists, so we pass a reference to that object. And the copy constructor will copy x, y, height and width values of the existing object referenced to by rectangle 3, 10, 20, 100, 200. We'll copy those to the property of the 4th object. So if we would execute these codes and look at the outputs, Here is the result of our default constructor, 2-param constructor, our 4-param constructor, and then the output of the object that was constructed by using the copy constructor. The last two, they're both different objects, but they have the same properties. Let's implement all this in the hands-on session in the next video. What I'm going to do here is, well, as usual, in the lib package, add package demo04 constructors and implement rectangle Java and add the 4 constructors to the rectangle class. And in the app package, add package demo4 constructors as well and use the new features in DrawingApp. Thank you for watching and see you in the next video.